Hi all, welcome to my channel. In this video, we'll learn about a linear algebra for ML and DL. So far, we have dealt with some pretty simple algebra, like linear algebra situations, right? In one of the problems which we solved, we had single variable and a single equation, right? We solved for x, and then we were solving for the X. And then we had a bank robber police example where we had a system of equations and it had two equations and it had two unknown d and d, basically the distance and the time. However, in linear algebra, in a given system of equation, so when I talk about in a given system of equations, uh, there could be many equations. There could be many equations. Uh, and also, similarly, we could have many unknown in each equation. So, could have many unknown in each equation. This could be, uh, generally we see this is this kind of a stuff. So, to have an example that's related to machine learning, let's describe a regression. So, let's have y equals to a plus b of x1 plus c of 2 plus so on up till of x. So now this y is basically the house price, and it can be any number, right? It can be like maybe $200,000 or $450,000 for individual data points, right? And then we will try to predict the house price using what's called a linear regression model. We will call a linear regression model. And to do that, we have like this y-intercept. So this is a y-intercept, which is basically going to be uh, like the average house price typically. And then we have variables like A, B, C. We have other variables like B, C, all the way to M that are associated with specific input values. So that they are the input values are x1, x2 till xm. So let's say the first input value uh, could be the number of bedrooms, right? So it can be so this can be any number of bedrooms, and let's say the x2 is let's say x2 is distance to school, distance to school, right? So the x2 could be, let's say, 5 kilometers or any number, right? This is an input value, and we can have many features. So so there could be there could be There could be M features. Okay, there could be uh, and each one of these feature and each one of these input values that we are predicting house price with, we're going to have an individual variable that we want to learn. So this variables we want to learn. So this A, B, C, and up to M. These are the variables we want to learn. So these are the unknowns. So these are the unknowns here. So what are the unknowns? A, B, C, all the A, B, C, all the way to M. These are the unknown values that we would like to be able to solve, and we can use linear algebra to solve this and those unknowns. So to cover the idea, having many unknowns in a given equation, let's talk about how we could have many equations in a machine learning problem. So this formula which we have here can we can have uh, a system of equation. Let's have a system of equation which has, let's say, y1, then we have y2 up to yn, and here we have a plus b of x1, 1 comma 1, and we have c x comma 1 comma 2, and up to x 1 comma m, and then similarly a plus b 2 comma 1 plus c 2 comma 2 up to the x of 2 comma m. Similarly, we have a b of xn minus 1 plus b xn comma 2 plus of the comma m. Now we'll enclose into square brackets on the either side of system of equation to denote that this is a system of equation, and then let's also have a vertical line here, um, like to represent where equal to sign would be, right? So we have one of these y values representing a different house price. So y1 could be again $2,000. Y2 could be like 350 $100. All the way through house n, and the final house and the so basically n is the final uh, house in the data set we're talking about. So in this data set, and let's say its price would be like, say, $70,000. Now then to build a model to try to predict uh, what house price should be, we use all of our input values so that we have distance to school for each of the house, for the first house, from the so for the second house, and all the way to nth house. So let's say this was the distance from school, right? So let's say first house, second house, and all the way to n. And similarly, we have the number of bedrooms for house number one, house number two, all the way to nth house. Uh, you know, and also similarly, we have the similarly for we have this the second house and nth house all the way through our mth feature. So this is mth feature, we have all the data here. Okay. Uh, so this is how we can represent the uh, so now this particular example, right? So this particular example of system of linear equation, and it's a perfect for solving with linear algebra. So for any of these given houses, we can call an given house where it's a house 1, house 2, or house n. We can refer the house I in the data set. So let's call for any house, for any house ith in the data set. Okay. So what yi will be the price of house, and xi1 to xim are its features. So any house, right, which is represented by I. So for example, for y2, I will be 2. Then the features will x21 and x2n will be the features of that particular house. Okay. So with the linear algebra, despite we having number of variable to solve for any number of columns in the system of linear equation, despite having so what basically what we need to which we need to solve for need to solve for we basically solve for parameters a, b, c all the way to f. This is what we'll solve for. So these are the unknowns we solve through. These are the variables. These are the unknowns we solve. So we use a linear algebra, to learn this parameter and solve for this. So this is how we can use this in a machine learning problem. Right? Uh, in detail, we are going to learn about that when we are going to learn about a particular, let's say, a linear regression. We're going to discuss in the future videos. But as of now, I think it is making sense, like how we can solve about the system of equation and what are the unknowns we are solving for using the linear algebra. That should be the takeaway here. Similarly, we also have in a deep learning where, for example, you have a certain input, right? So input layer we have, let's say we have certain some kind of a input, right? And then that input and it is passing to the hidden layers. Hidden layers we will see that in detail once we discuss about deep learning. But point is, we kind of so this is how it is connected and stuff like that, right? Let's say we have some connections and some sort of a network we have, and we have certain, let's say, output here. Okay, so something of that sort. So this is our output layer. So this is our output. Let's say this is our input. Yeah, these are hidden neurons we talk about. So basically, it predicts the output, the probability of one of the outcome class. Let's say it's a classification problem. So this probability is again an array of probabilities which predict. We, let's say, have an image or a image, and these are the pixels which is going through this network, and network will learn. So what it will learn? So what are the unknowns we are talking about? So we have weights and biases are the unknowns which we are talking about here. So every neuron has certain weight assigned to it, bias, and these are the learnable parameters we are talking about. And using linear algebra, we basically solve that. So this is a kind of a brief introduction about how linear algebra is related to machine learning and deep learning. So again, the key takeaway here is that we have certain unknown parameters which we need to learn and use linear algebra to basically solve for that. That's all in this video. I hope you like this video. See you in the next video.